Hello everybody. Welcome to the productionization video in the large-scale machine learning section of ML Expert. So far, we've gone over data ingestion that involved the clickstream, the data processing jobs, data storage, and data orchestration. As well, we went over the data and model exploration. We talked about what workspaces we can use, how to control data access, model access, and how to encourage collaboration when developing models, features, and labels. Then we talked about experiment design and impact estimation and the various ways that we could do that. So, are we ready to run the experiment? Well, in general, no. What we need to do before we do that is reduce the room for human error. When we say reduce, we want to reduce as much as is practical to help us reduce the chance for some problem. So let's say we have a team. We have 3 software engineers, 2 data engineers, 2 scientists, 1 manager, and 1 UX designer. This is a fairly small team, and let's say that each person has a 1% chance of making a mistake each experiment that we run. When I say make a mistake, I'm not implying that it's anyone's fault. People make mistakes. If we engineer systems to expect machines to fail, we should absolutely design and engineer systems such that we expect humans to fail. So with these odds in this size team, if we run an experiment every month, then over the course of a year, there's a 66% chance that something will go wrong. If we increase the team size a little bit, there's an 85% chance. And let's say we have a fairly large team or even a small organization which supports multiple teams' goals in terms of machine learning, then we have nearly a 100% chance of something going wrong across the year. Now, these things going wrong could be extremely obvious, such as a complete outage of the service, or it could be extremely subtle, such as swapping 2 feature columns by accident in some data job. This may go on completely unnoticed for some time. And especially when you have teams this large or you have some business impact that's especially large, these errors can really be detrimental to the overall goal. So what can we do about these? Well, we talked about data ingestion. Now, specifically for Clickstream, what we can do is have automated tests which verify that performing some action on the website leads to some event making its way into the storage layer after it passes through the ingestion process. We can use tools such as headless browsers to make this an automated test. Some examples of browsers that have headless versions are Chromium and Firefox. Tests like these will ensure that the clickstream events are accurate and complete. Now, for data processing jobs, we can use unit tests like PyTest and run those tests against production data such that we can validate to some extent, at least, that our data processing jobs are behaving correctly. Now, beyond that, we can use version control and code reviews to make sure that others on the team get an opportunity to look over someone's processing jobs. Next up, we have data storage, and for that, we should validate all of our schemas. We should make sure that we have consistency across all of the partitions that we arrange, and we should make sure that the data is actually preserved the way that it's entered in terms of ingestion. Again, most of these can be tested and verified after we do some sort of clickstream test through a headless browser. Finally, for data orchestration, to make sure that all the joins and aggregations are happening correctly, we'll have to write unit tests and have version control for our Airflow DAGs. Now, beyond just the ingestion, we talked about the data and model exploration. Now with this, we need to make sure that whatever environment we had in our workspace is the exact same environment that will be used when it comes to serving production traffic. For instance, let's say that we were doing data and model exploration with some version of TensorFlow. We have to make sure that that exact same version of TensorFlow is used in the production environment. One way to do this is with a requirements.txt, which allows pip, the Python package manager, to install the exact packages that you want. So generally, you would have a workspace environment and a production environment, and whenever you wanted to productionize a particular model data combination, you would make sure to deploy that particular requirements.txt to the production environment. Now, in terms of data, we need to make sure that the data itself is versioned and we know the provenance of that data. All that means is we have to make sure that we know the origin of that data and the different transformations or aggregations or joins that that data has had. This is to ensure that whatever exploration that we did is repeatable amongst our colleagues. Now, additionally, this can include other transformations that we did in our exploration, such as TF-IDF or feature scaling. All of these things have to be noted and made available elsewhere to ensure repeatability. Now, in terms of data, S3 offers data versioning. You can also use DVC or data version control. Those of you familiar with Git will find that to be somewhat similar. Now, as for the model, we have to know what are the model parameters that we've trained, what are the hyperparameters, and what was the overall performance of the model. This should be easily available at any stage of the model development. Now, there's many tools out there that do both model and data management. MLflow, MLMD, which is ML metadata, SageMaker Studio, and several others will help in the overall process of getting some data into features and labels, getting that tied to some model, and eventually trying to productionize that model to serve real traffic. Now, we also talked about experiment design and impact estimation. Now, when we want to productionize a model for an experiment, we should at all times be tracking this experiment and always be able to answer who is this experiment affecting? What about those people is it affecting? Where is it affecting them? And for how long will it be affecting them in terms of the experiment duration? This is an effort to avoid experiment collisions. It also provides a way to quickly look up past experiments and to be able to see what worked and what hasn't worked. Now, even though it's pretty easy to kind of toss away what experiments didn't work, it's equally as important to note down what didn't work so that future teams don't end up repeating your same experiments. So, even though we'll talk more in depth later about deployment, one of the goals of productionization is to synchronize everything on deployment. And by everything, we mean the model, the data that that model expects, and the environment in terms of the software packages. All of these things have to fall in place together. So, in general, we talked about ways to verify automatically that all of our processes are occurring in the way that we expect. This is in an effort to reduce the human error that can happen when transitioning a model from purely exploration or experimentation into some production environment. That wraps up the productionization video in the large scale machine learning section of ML Expert. Thanks for joining, and we'll see you next time.